this video is going to be presented the history of snare drums, manufacturing processes, music influence, and the physics behind the instrument. The snare drum is a small double-headed drum having wired stretch across the bottom head to create a reverberation. The snare drum has evolved as the meant to be known as we know it today. Technology has influenced the sound and design of the snare drum because of new technologies allowing better design such as those made with metal. Also, the processes used to manufacture the snare drum has changed over the years. There are many different styles of music across the world, and the snare drum has influenced most of them to provide the listener with rhythmical music.
The drum is said to be man's oldest musical percussion instrument. In ancient time, it was a piece of some animal skin stretched over the end of an empty log. From the original simple drum, several types of drum developed in other parts of the world. One of these includes the tower. The tower is considered to be the earliest form of a snare drum, the first one with only one catgut snare. It is called snare drum because it has one or several cables at the bottom of the drum of either metal, plastic, or catguts. Sounds of a snare drum is produced when the stick made of wood hits the drum, creating a vibration. This causes the snare to vibrate against the head of the drum. The sounds that a snare drum might produce might vary depending on the tension, material, and design of the snare cables. Most often, a dry, rattling sound is more commonly desired for this instrument. Construction of snare drum can be traced to Egyptian Arabian. Usually in Egypt, the snare were located in one side of the drum and were made with animal parts.
The snare drum was also introduced by the Arabs passing through Spain and also by the Turks passing through the northern Europe. This instrument had a wide range of sizes through different times and places without ever having a final shape. For example, the tabor used in England was not very deep, while the snare drum province used in France was much deeper.
Around the 1400s, the drum was used in warfare by the Swiss military army to give signals to the soldiers and to create noise and motivate fear to the enemy. Larger versions of the snare drum led to the creation of a new snare drum type called the side drum. In the 17th century, a new method to tension the snares using screws resulted in a change in the sound of the drums, more similar to a snap. In the beginning of the 20th century, Robert Dansley founded a drum company, and he also found a way to cancel the drums instantly, allowing the drum case to be played like a thumb-thumb, marking a new drum era. Here is the complete manufacturing process of a snare drum. Enjoy it.
The snare drum influenced the military in early years to form battle and pipe bands, but not only the military. The snare drum has success. Nowadays it can be heard in almost all types of music. For example, in reggae music, the snare drum is often tuned very high to give it a timbal type sounds. Also, some reggae drummers use additional timbal or high-tuned snare to get this sound. In rock and roll, it emphasizes a steady backbeat pattern such as quarter notes on the backbeat to give rhythm to the song. In jazz, the use of the snare drum is known as copying, supporting and interacting with the other musician in the band. The snare drum also plays a key role in matching bands. It is the tempo control instrument for the entire band. The specific characteristics of that sound will depend on the shell, membrane properties, striking velocity, sticking area, membrane tension, and room acoustics.
Here is the lowest frequency vibrational pattern in a circular membrane. This circular membrane is a piece of Danish rubber dam stretched over a tube of PVC pipe and held in place by the several rubber bands. In this frequency, we can appreciate how the lowest pattern movement as one piece moving together. In the second pattern, for the same membrane with a higher frequency, half of the membrane moves up while the other half is moving down, and there's a line in the middle, right across the diameter, called the node, that doesn't vibrate at all. Here's the third pattern, and we can appreciate two sections, where two opposite sides of the membrane move up together while the adjacent sections move down, to have a total of 4 regions that move alternating up and down. In the fourth pattern, the center of the membrane moves opposite to the outside edge. Different northern patterns can be excited by different techniques, causing the change in harmonic content of the snare drum sound.
Gordon Reed made an experiment where he wanted to see what happened to the center of the membrane and the cable by hitting the upper membrane with a stick. Since the upper membrane was hit, it was forced down and made the lower membrane to vibrate. At some point, the vibration of the lower membrane will hit the cable, making it vibrate too. Because both the membrane and the cable are in tension, somehow both are elastic. They will return to rest when the energy is dissipated.
However, since the drum head and the cable do not have the same properties and are very different objects, this is not a real case. Reed explains that in real-world situations, when the stick hits the upper membrane, the cable will go down. Sometime after that, it will go up again and hit the lower membrane. He said that at this moment the cable and the membrane will be giving energy to each other, exciting the new modes of vibrations and also new frequencies. Sometime later, they will hit each other again, giving more new frequencies and vibrations. This will continue until the energy is dissipated.
In conclusion, the vibrations of a snare drum depend on the drum shell, the tension of the lower and upper membrane, and the tension of the snare head and the material of the shell. All of these factors combine to make the snare drum sounds unique and to give us a wide variety of snare drums. Also, these vibrations will vary on what type of support the snare drum is on. This because of the standard support of a mechanical coupling between the drum and the stand make to the sound to lose some energy. Math and physics can help us in the understanding of the sound, also the waves and vibrations that any instrument possesses. But there is no method for designing, manufacturing and playing any instrument to produce a perfect sound or vibration.